Section 8.3, Example 3 on page 518, we have you can use the properties of rotations to solve problems. Example 3 says in the diagram, WXYZ is a parallelogram, and T is the midpoint of the diagonals. How can you use the properties of rotation to show that the lengths of the opposite sides of the parallelogram are equal? So we have a parallelogram. T, this point right here in the middle, cuts the diagonals in half because it is the midpoint of each diagonal. And we're trying to show that the opposite sides, so WZ, XY, and then ZY, WX, have the same length. Because T is the midpoint of the diagonals, XT and ZT are equal, and WT equals YT. So I've marked those pieces with congruent symbols because the lengths are the same. Since W and Y are equidistant from T, that is W and Y because these lengths right here are equal, and the measure of angle WTY is 180 because we have a straight line, you know that the rotation of 180 degrees about point T of W is Y. Similarly, the rotation of 180 degrees about the point T of X gives us Z. Therefore, you can rotate every point on line segment WX in the same way, so the rotation of 180 degrees about the point T of segment WX will give us segment YZ. Likewise, you can map the segment WZ to the segment YX. Because rotations are rigid motions and preserve distance, the length of WX equals the length of YZ, and the length of WZ equals the length of YX, which is exactly what we wanted to show. The work for this problem is written out on the next slide, and now I would like you to try homework number 5 on page 519. For exercises 5 and 6, use the diagram at the right. TQNV is a rectangle. M is the midpoint of the diagonals. Use the properties of rotations to show that the measures of both pairs of opposite sides are equal in length.